Hi, this is Mr. Mac. This is a talk about solving systems of equations in two variables, and this one basically deals with systems where the equations in two variables are not necessarily linear, or in other words, the equations are not necessarily straight lines. Now, first of all, let's take a look at the system that we have before us here. X squared plus y squared equals 25. Oops. X squared plus y squared equals 25, and x plus y equals 7. Now, this equation right here is a linear equation. It's first degree, and linear equations have graphs that are lines. This equation is not a linear equation, however. It is a quadratic equation in two variables, and it turns out that the graph of this particular equation is a circle. Now, what I'd like to do is I'd like to show you two ways to solve this system. The first way is to use substitution, which is a method of solving systems that was presented to you back in an earlier video in our course. Now, remember, in substitution, what you do is you pick one of the equations, and this time we're going to pick this equation, and you solve for one of the variables in that equation. We may as well solve for y. In other words, y equals 7 minus x is that equation rewritten so that it's solved for y. And then you substitute that value for that variable back in the other equation. So the first equation would now become x squared plus, really it says y squared equals 25. But what I'm going to do is I'm going to put the value of y in that I got for this other equation. So that's 7 minus x. Now notice we have an equation with just one variable. So let's get to work here. We have x squared plus, now guys, it is extremely important when you're squaring a binomial that you realize that you have to write the binomial down twice and FOIL it out. You get a middle term. You do not get just 49 plus or minus x squared. What you get is the first term squared minus 2 times the first term times the second term plus the second term squared. Now, so 49 minus 14x plus x squared is what you'll get if you square this binomial. Now, I'm not going to spend time in the video doing that, but if you are having trouble accepting this, or if you don't know how to do this kind of the way I did, then pause the video and actually FOIL these two binomials together and simplify it. That's what you'll get. Now, let's clean some things up here. We have an x squared, we have another x squared, that's 2x squared. We have minus 14x, and we have plus 49, and we have equals 25. Now, when we're solving quadratic equations, we ordinarily write the equations so that everything is on one side and there's 0 on the other side. So we'll subtract 25 from both sides. 2x squared minus 14x plus 24 equals 0. Now, that's what we get when we subtract 25 from both sides. And now, before we go off like a herd of turtles, you all have heard of turtles, I'm sure, notice that there's a factor of 2 in all three terms of that quadratic polynomial. So we could actually just divide both sides of this equation by 2 to get x squared minus 7x plus 12 equals 0, because 0 divided by 2 is still 0. Now, on this one, we could probably factor this equation to solve it. But, and if you know how to do that, that's great. It's fine with me if you do that. But what I'm going to do here is I'm just going to make use of what I'm hoping is prior knowledge. In other words, if ax squared plus bx plus c equals 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This is called the quadratic formula, and it's something that's supposed to have been presented in Algebra 1, and I find that most students have actually memorized this, and this is important. So we're going to make use of this. In our case, a is 1, b is negative 7, and c is 12. So when we plug it in, we get x equals 7 plus or minus the square root of b squared. Now, negative 7 squared is 49, and then that's minus 4 times a, which is 1, times c, which is 12, all over 2 times 1. So we get x equals 7 plus or minus the square root of, now, 4 times 1 times 12 is 48. 49 minus 48 is 1, and that's all over 2. So we get 7 plus or minus 1 over 2, which is 8 over 2 or 6 over 2. So we get 4 or 3 for x. Now, when we're solving systems of simultaneous equations, it's not enough to just get what x is. We need to say what x is and what y is matched with that x. So now we need to put 3 and 4, which are the two x's we got, back in one of these equations to get the other value. Now, folks, if you have a system that has a linear equation, you should plug back in the linear equation to get the other values, because otherwise you may generate some values that aren't actually on the intersection of the two graphs. But when you have a linear equation, you should plug that back in there and see, and to get the other values. So we're going to use x plus y equals 7 to get the other values. So now, if x equals 3, that implies, x plus y equals 7 implies that y is equal to 4, because if they add together to make 7, then when x is 3, y is 4. If x equals 4, that implies, using x plus y equals 7, that y equals 3. So now we have the ordered pair 3, 4, and we have the ordered pair 4, 3. Now, at this particular point, it is important to check to make sure that your answers are right. So we're going to put these in the other equation, which was x squared plus y squared equals 25. So on the first one, we have 3 squared plus 4 squared equals what we're hoping, 25, right? Well, that's 9 plus 16, and that is 20. I don't know what I'm doing here. That is 25. So it checks. So we get to keep 3, 4. And it's pretty obvious that 4, 3 is going to work as well, because 4 squared plus 3 squared is the very same thing as 3 squared plus 4 squared, or 25. So that one checks as well. So the two solutions to this system are 3, 4 and 4, 3. Now, that's an algebraic way of solving a nonlinear system. Well, this is a system that has at least one nonlinear equation. So what I'd like to do now is I'd like to go back and I'd like to solve this again, but this time we're going to use the technology of the graphing calculator to solve the system. So let's just go ahead and make another page with the same system. We have x squared plus y squared equals 25. And we have x plus y equals 7. Now, what we're going to do in this case is we're going to put these equations in our graphing calculator, and we're going to ask the graphing calculator to tell us the places where the graphs intersect. Now, you cannot put something in the graphing calculator unless it is in y equals mode. Now, this second equation easily becomes y equals 7 minus x. But the first equation is going to take a little work. x squared plus y squared equals 25. And we want to solve this for y. So the first thing we'll do is we'll subtract x squared from both sides, and we get y squared equals 25 minus x squared. Now what we're going to do is we're going to take the square root of both sides of this equation. Now guys, at this particular point, I'm just going to tell you, when you take the square root of both sides of an equation, you have to put a plus or minus sign on one side or other of the equation. In other words, if y squared equals 25 minus x squared, then y equals plus or minus the square root of 25 minus x squared. See, when you take the square root of both sides, one side or the other, you have to put a plus or minus sign. We'll talk about more about that in a later video. Now, let's take a look at what that means. In this spot, then, I'm going to first put 7 minus x. Now, in y2, I'm going to put, and you see, when you have y equals plus or minus the square root of 25 minus x squared, you can't put a plus or minus sign in there. What you have to do is you have to use two of the y variables. One's going to be plus square root of 25 minus x squared. The other's going to be the negative of the square root of 25 minus x squared. So on y2, you press square root, and then 25 minus x squared, and close paren. Now, for y3, I'm going to put the opposite. Now, let me just point out here, there are two keys on the calculator that seem to be the same. There's the key below the 3, which is the negative sign, and then there's the key to the right of the 6, which is the minus sign. Now, if you press the key to the right of the 6 here, when the calculator got to this, it would call you a syntax error, because the key to the next left of the 6 is the subtract sign, and what the calculator does is it interprets that key to mean take the thing that's in front of the minus sign and subtract from that the thing that's after the minus sign. But if you put it first, there isn't going to be anything there. It won't be able to do that. But the key below the 3 actually gives you the negative sign. Now also, take a look at the two symbols. Do you see that they're different? If you're told syntax error and you're trying to do a negative or something, then what you've done is you have actually put the subtract sign when you should have put the negative sign. Now, we then do second x squared again, and then 25 minus x squared, and close paren. Now, if we press zoom 6, we'll get the standard negative 10 to 10 window, but the calculator isn't going to do this x squared plus y squared equals 25 real well, because it has a little trouble getting down to the x-axis. Well, let's just do this, zoom 6. See, and notice it didn't go all the way to the x-axis on these two, but it actually should have. Now, it's better if you have something like this to try zoom 4 for decimal, which is okay except it's not quite big enough, or zoom 5, which is zoom square. Zoom 6, zoom 5. Okay, now what we got in that particular case is at least we got the pixels so that the x and y axis are equal. So can you see that what we really have here is a circle and a line? Now, you can't really see the points over here in the first quadrant real well, so let's go to Window, and we'll make x min 0, and we'll make y min 0, and see what that does for us. See, now we can see this a little bit better. Let's change the window here. Let's let y max be 6, or x max be 6, and let's let y max be 6 as well. Now it's going to distort the graph a little bit, but you can see it a little bit better. Now, you can probably see here that there are points of intersection. If you're still having trouble with that and this is not doing real well, maybe we need to zoom in a little bit more. But let's just go ahead and go to getting the intersections. Now, to get an intersection, once you have two graphs, you press second, trace, And number 5 in the calculate menu is intersection. Now, the calculator is going to ask you a couple of questions. Question number 1, what is one of the curves you want? And now, right now it's saying, do you want to use y equals 7 minus x? And that's one of the curves that we do want to use. So yes, all you need to do there is press enter. Then it's saying, now how about square root 25 minus x squared for the second curve? And yes, that's one that we want to use, so press enter. And now it's going to ask for a guess. Now notice the way I've set up the window, it's right on the point already. So let's move it off, press the arrow to move it off a little bit. And if I move it to the left of 3, then it's probably going to find 3 as the guess. So if we press enter, it finds 3, 4. Now, so that's one of them. But we're thinking there's probably another point here too, right? So let's, again, go second trace, that's the calculate menu, 5 for intersection. First curve is y1, second curve is y2. And now the guess, let's move to the right over to the place where we think the point of intersection is and try entering again. When we do this time, it finds the point 4, 3. So you can find your points of intersection using the graphing calculator. Remember, to put them in the y equals register, you have to solve them for y and then put them in. All right, now let's go to a system that is not linear at all. We have x squared plus y squared equals 45, and we have y squared minus x squared equals 27. Now, this one we're going to try algebraically, and then we're going to go back and we're going to do it graphically as well. Now, first of all, this second equation probably should be written as negative x squared plus y squared equals 27. And then the first one becomes x squared plus y squared equals 45. Now, I'm hoping as you look at these two, you say, well, Mr. McFarland, if I just added these equations together, the x squareds would go away. Now, isn't that nice? So let's add them together. X squared goes away. We get 2y squared equals, now 5 plus 7 is 12, 4 plus 2 is 6, plus 1 is 7. So then when we subtract 2 from both sides, we get y squared equals 36. And so now what we're saying is y is going to be equal to either plus or minus 6. Because if we take the square root again of both sides of this equation, realize that when you square 6, you get 36. But also when you square negative 6, you get 36. Anytime you take the square root of both sides of the equation, you have to introduce a plus or minus sign on one side of the equation or the other. Now, that doesn't always mean that they'll both work, but you have to at least admit the possibility of it and take a look at it. Now, since we have plus or minus 6 for y, we're going to put y equals 6 back in the first equation, and that gives us x squared plus 36 equals 45. If we subtract 36 from both sides, we get x squared equals 45 minus 36, which is 9. So take the square root of both sides, we get x equals plus or minus 3. So we're saying the possibility is 6, 3, and 6, negative 3. Now, let's try y equals negative 6. We have x squared plus negative 6 squared equals 45. So that gives us x squared plus 36 equals 45. And I hope you can see that that's the same equation that we have up here. So we're going to end up also with x equals plus or minus 3. So now we have the ordered pairs negative 6, 3, and we have the ordered pair negative 6, negative 3. Now, in this particular case, we do need to check these because with the squaring and square rooting and so forth, some of these points may not work in both of the equations. Now, we know they all work in the first one because that's where we got them. So let's try them in the second one. Now, we have y squared minus x squared equals 27. So if we put negative 3 or 3 in for y, oh, wait. Oh my goodness. None of these points are what we got. Let's go back and do this right here. Notice y was 6, x was plus or minus 3. So we get 3 comma 6 and negative 3 comma 6. And here we have 3 comma negative 6 and negative 3 comma negative 6. Okay, that makes more sense. So we have plus or minus 6 squared minus plus or minus 3 squared. Now, whether x is 6 or negative 6, when we square it, we get 36. And whether x is 3 or negative 3, when we square it, we get 9. And 36 minus 9 is 27 in both cases. So we get to keep all 4 of these points. All right, now I'm going to pause this video because one of my students has come by, and I'll finish up with technology on this in just a moment. Hi, I'm back. Now, we're going to do this one again, but this time we're going to do it using technology. So let's just do this. I'm going to capture the problem. Oh, that's ugly. Let's try it one more time, see if it won't do a better job. There we go. Why is it doing that? Huh. Okay, well, there we go. Anyway, now when we're doing this with technology, we need to have each of these solved for y. So the first one becomes y squared equals 45 minus x squared. So y is equal to plus or minus the square root of 45 minus x squared. And the second one becomes y squared equals x squared plus 27. So y is equal to plus or minus the square root of x squared plus 27. Now, that means it's going to take 4 places in our calculator to do this. So, first of all, we'll do square root 45 minus x squared. The second one, we'll do the negative of the square root of 45 minus x squared. The third one becomes the square root of x squared plus 27. Since I already have most of this in here, I'm just going to do that and cheat a little bit. 27 plus x squared is the same thing as x squared plus 27, right? And the last one, the negative of the square root of x squared plus 27, close paren. Now, let's go back to Zoom 6, the standard 10 by 10 window. All right, so you can see we have kind of this oval thing in the middle. And actually, guys, it does go to the x-axis. The calculator just has difficulty knowing that. And then we have a branch up at the top and a branch down at the bottom. So let's first go second trace, and we're looking for 5, the intersection. And so notice the blinker is on the upper half of that oval. We want to use that one, so press enter. Now, the second curve is on the bottom half of the oval. We don't want to use that one, so press down arrow. Now we're on the top half of the curve. We do want to use that one, so press enter. And now the guess. Move your blinker over close to where the point of intersection is you want, and press enter, and it'll find 3, 6. Now, we can do the others. Second, calc, 5 for intersection. The first curve is y1. That's one that we want. Yes. The second one is this one. Yes. Now, if we want to find this intersection over here, move the blinker when we're doing the guess over close to that point and press enter, and it'll find negative 3, 6. Now, let's go ahead and find one of the intersections on the bottom, and I'll leave the other one to you all. So once again, second, trace, and then 5 for intersection. Now, the first curve, this time we want to use the negative of the square root of 45 minus x squared. That's this bottom curve. Yes, we want that. And the second curve, no, we don't want that top curve. We want the negative of the square root of x squared minus 27. And so that's the second curve. We press enter. Now for the guess, I'm going to move the blinker over here to find, what is this going to be, 3, -6? Yeah, 3, -6. And so that's 3 of them. You can certainly find the fourth one, I'm sure. Now, that should give you enough skills to be able to do the problems that you're asked to do in this section, and it should give you enough so that if you have a question on the semester exam in nonlinear systems, that you'll be able to solve that using either the calculator or the quadratic formula. So that takes care of it. We're done.